Hello, myself Shubham Kogne. I am final year IT student from Dr.D.Y.Patil College, Pimpri, Pune. Today I am presenting the current progress on my project titled Intelligent Ransomware Defense System with Digital Forensics Integration. In this video, I will quickly walk through the system workflow, code architecture, front-end back-end integration, and the various core components I have implemented in the project. I will also show the current working dashboard and explain what parts will be completed in the next stage, especially the attack simulation using the virtual machine. So let's begin. So this is the overall workflow that I have designed and implemented. The system works as a host level lightweight agent that continuously monitors file activity in real time. So this architecture is implemented as a pipeline of multiple layers. So first layer is file watcher system or file watcher layer. It uses Watchdog to observe the file events like file creation, modification, deletion, renaming. So it converts raw events into normalized file event objects. Next layer is entropy calculation engine. So it computes Shannon entropy from the first few kilobytes of a file and it acts as a early ransomware indicator. Next layer is anomaly detection and greater number module. So it maintains a rolling statics like mean and standard deviation per file type. So it computes greater score, and you can understand greater score as how far the current entropy deviates from the historical behavior. So next layer is explainable AI layer. So for suspicious events, sharp explainability is automatically computed. The system extracts the top contributing features and the sharp values. Next layer is alert and logging module. So it stores each event with all the metrics plus explainable AI data into SQLite database. So it also triggers WebSockets alerts to the dashboard in real time so that you can see all the events that are happening in your system in real time on the dashboard. And finally, there is user interface dashboard. So I have built this using React and it shows real-time alerts, event logs, then explainable AI visualizations, various entropy trends and forensic bundles and much more things. So this is the full end-to-end architecture that is currently implemented in the code. Okay, now let's move to the actual code implementation part. So this is the core folder is the main component that includes all the files that I just explained in the workflow of the system. So the first file is like anomaly engine, or you can say, sorry, entropy engine. So this entropy engine it reads the first 4 KB of a file and computes Shannon entropy. So high entropy can indicate encryption or ransomware activity. And for Shannon entropy, the formula is implemented here. The next file is baseline store. So it calculates the greater score. For example, if a docs file usually has entropy like 4.1 and suddenly the entropy rise to 7.8. So the greater spikes becomes a strong anomaly indicator. Next one is ML learning model. So this model is implemented in this models folder. So I've currently created a dummy file that will just simulate like a actual model that we are going to use. So this model takes uh, two parameters like entropy delta and Gretel score, and it outputs an anomaly probability score. So this score is then combined with other heuristics to produce the final threat score. Then there was explainable AI layer. So one of the most important part of my system is the explainable AI integration. Whenever an event is classified as suspicious, SHAP values will be generated, then the feature importance will be extracted, and then the top contributing features are stored. And this everything will be saved in a database and displayed in the dashboard in real time. For example, for a suspicious event, the explainable AI output may show like entropy contributed 55%, the entropy delta contributed 31%, or the greatest score contributed 21%. So this will help the examiners or any technical person to understand why a file was considered as ransomware like. Then there is forensics folder. So it contains two main files, bundle exported and logger.py. So every every event that is processed is permanently stored in the events DB. So this is SQLite database, and along with SAP data if the activity was suspicious. Then the logger also sends this data to the real in real time to the dashboard using web sockets. So you can get instant updates. There is bundle exporter.py. So a forensic bundle is a is a zip file that contains full event record, explainable AI data, file snapshots, and manifest.json. This allows proper forensic investigation on post-incident reporting. Then there are other folders too. Let me explain you one by one. So all the this is the main file where all your sorry this is the main entry point where all your code will be executed, and this API server.py it contains the all the paths that will be used to show data in the dashboard in real time. And to show the data in real time, we have used WebSocket, and you all and the backend is implemented using Fast API. Now let's run the backend and see what happens in the dashboard. So the I will run the backend using UVCon. This launches the Fast API server plus WebSocket event loop. So you can see the application startup complete. Then we'll start our front end. So as everything is implemented in React, so this is our dashboard, and this is the overview of whole dashboard. You can see like what are the total events, what are the suspicious activity overview, what was the average entropy, and graph will show the entropy trend on your current uses of your system. Then you can here we have provided a run scan button which you can use to normally scan your files like how we use our antivirus system. Then there is alerts section where this is the main section where you are going to get real-time alerts for suspicious activities if any in your system. Then there is events. So if you have seen your task manager in your Windows system, so this is going to be similar to that. And this is the forensic section where everything will be stored, like the logger system, which you can later use to regain your files which were encrypted. So this was the whole dashboard. So far the entire backend pipeline is functional, like the file watcher, entropy, baseline, YAML, and the at automatic SAP explainability, forensic logging into SQLite, then real-time WebSockets alerts, React dashboard with charts, tables, and bundles, and static file serving for forensic bundles. So in next phase, we'll include more robust machine learning model tuning for higher accuracy. Then Lime integration will be there. It is already planned in the architecture. Only the integration part is remaining. Then virtual machine based attack simulation using custom ransomware scripts. So later we will show how the actual working of our system will be using virtual machines and normal Python scripts. Then the testing real-time behavior against control encryption process. Then also the recovery part is remaining, which will be implemented in later part. And this is the current state of our system, and it is working end to end. In the next update, I will demonstrate the ransomware simulation running inside a virtual machine. So thank you for reviewing my progress. The system is now stable, functional, and ready for the simulation phase. I will continue refining the machine learning model and enhancing the detection accuracy. If you have any suggestions or changes, I would happy to implement them. Thank you.